Good morning, students. First of all, I am sorry that you had to wait. There were some technical issues. Anyways, today I am going to start beta gamma functions. So, beta gamma functions are a part of improper integrals. First of all, let me write the gamma function. Gamma alpha is 0 to infinity e to the power minus x, x to the power alpha minus 1 dx, and beta function is of the form 0 to 1 t to the power m minus 1, 1 minus t to the power n minus 1 dt. So, you can see that both gamma function, this one, and beta function, the second one, there are some improperness. For gamma function it will be based on the value of alpha, and for beta function it will be based on the values of m and n. So, first of all let me discuss the gamma function. So, gamma function is 0 to infinity dx. Now, you can see in gamma function the integral involved are two ways improper. First of all, it is improper due to the presence of infinity in its upper limit, and next if alpha minus 1 is less than 0, then also the integrand becomes unbounded at the point x equal to 0. Thus, to discuss the convergence of gamma function, let me break the interval of the integration, that is, let me write 0 to a e to the power minus x, x to the power alpha minus 1 dx, and plus a to infinity e to the power minus x, x to the power I alpha minus 1 dx. Now, you can see that let me call the first integral as I1 and second integral as I2. I2. So, this one is what? If alpha minus 1 is less than 0, then it is of type 3 integral. And I2 is type 1 integral. So, we have to discuss the convergence of both the first integral I1 and second integral I2. We would like to find the conditions. So, I1 is 0 to a e to the power minus x, x to the power alpha minus 1 dx. So, you observe that I1 is proper if alpha greater equal to 1. If alpha greater equal to 1, then what happens? If alpha equal to 1, it becomes x to the power 0, so 1. But if alpha greater equal to 1, then also the power will be power of x will be positive, and then it will become proper. Thus, let us consider the case when alpha less than 1, what will happen? So, in that case, to discuss convergence of I1. So, now let f x be e to the power minus x, x to the power alpha minus 1. Then I1 I can say 0 to a f x dx, 0 to a f x dx. So, let us apply limit test. So, apply limit test, then what will happen? F x by g x. Okay. So, what is, first of all we need to choose g x properly. Okay. So, let g x be equal to x to the power alpha minus 1, then f x by g x is equal to e to the power minus x by x to the power alpha minus 1 divided by x to the power alpha minus 1, that is equal to e to the power minus x. And so, limit. Now, the improper days, if any, is at the point x equal to 0, you can see at x equal to 0. So, we should put the limit x equal to 0, f by g, that is going to be equal to e to the power minus x, so 1. Therefore, the limit is not equal to 0 and finite. So, if you remember the statement of limit test, then 0 to a f dx and 0 to a g dx converge and diverge together. That is, if g dx converges, then f dx also converges, and similarly if g dx integral g dx diverges, then integral f dx will also diverge. So, now we have to find that what will be the condition of convergence or divergence of the integral g dx. The same will be the condition of convergence and divergence of f dx. So, now what is g? G is x to the power alpha minus 1. So, integral 0 to a g dx. So, that is equal to integral 0 to a x to the power alpha minus 1 dx. So, that is equal to, we should write it in the form dx upon x to the power 1 minus alpha. This form is familiar to you, and you know that for type 3 integral, this integral converges when the power of x is less than 1. So, which converges for 1 minus alpha less than 1 when 1 minus alpha greater equal to 1. That is for alpha greater than 0, it converges and diverges when alpha is less or equal to 0. And so, by the limit test, integral 0 to a f dx, that is integral 0 to a e to the power minus x, x to the power alpha minus 1 dx converges for alpha greater than 0, diverges for alpha less or equal to 0. So, this is for I1. Next, let us come to I2. So, what is I2? I2 is a to infinity e to the power minus x, x to the power alpha minus 1 dx. So, this is clearly improper due to the upper limit infinity, and this is a to infinity e to the power minus x, x to the power alpha minus 1 dx, and it is of type 1 integral. So, now again let us apply limit test. Apply limit test. So, now let us take g x as 1 upon x square. Then f x by g x is e to the power minus x, x to the power alpha minus 1 by x square, that is equal to x to the power alpha plus 1, and this is f x by g x, sorry, if it is x to the power, g x is 1 upon x square. Then, so g x is x to the power minus 2, then the limit becomes e to the power minus x, x to the power alpha plus 1. Therefore, now we have to apply limit x tends to infinity. So, this is equal to f by g equal to limit x tends to infinity e to the power minus x, x to the power alpha plus 1, and it can be proved that this limit is 0 for all values of lambda, for all alpha, for all alpha. Therefore, the limit becomes 0. Okay. So, now by the help of limit test, we can conclude about only the convergence. Since the limit is 0, we cannot say anything about divergence, we can say only about convergence. Okay. So, if integral g dx converges, then integral f dx also converges. So, this implies if integral g dx a to infinity converges, then integral a to infinity f dx converges. Okay. So, now integral g dx is what? A to infinity. Okay. Let me write in a new page. So, now integral a to infinity g dx, this is equal to a to infinity dx by x square, always converges, because it is of the form dx by x to the power p, and this type 1 integral is convergent if p is greater than 1. So, this converges. Therefore, we can say a to infinity dx, a to infinity, this is what is f x, f dx. So, a to infinity x to the power alpha minus 1 e to the power minus x dx converges. Okay. So, now let us come back to the form of the gamma function. It is of the form a 0 to infinity e to the power minus x, x to the power alpha minus 1 dx. So, we had split it into 0 to a e to the power minus x, x to the power alpha minus 1 dx plus a to infinity e to the power minus x, x to the power alpha minus 1 dx, where a is some number greater than 0, some finite number greater than 0. And so, we have called this as I1 and the second integral as I2. So, what we have seen that I1 is proper when alpha greater equal to 1, I1 is improper and convergent when alpha greater than 0, that is when 0 less alpha less 1, because for alpha greater equal to 1 it is proper, and I2 is improper and convergent for all values of alpha. So, combining these two cases, we can say that thus gamma alpha, which is of the form 0 to infinity e to the power minus x, x to the power alpha minus 1 dx. So, this is defined for alpha greater than 0. When 0 less alpha less 1, it is improper and convergent. When alpha greater equal to 1, so it is also improper as a whole, because I2 is improper. Although I1 is proper when alpha greater equal to 1, but I2 is improper, but convergent even if alpha greater than equal to 1. So, that is about the convergence of gamma function. Okay. So, let us start beta function. Beta function. So, beta function is defined like beta mn 0 to 1 t to the power m minus 1 1 minus t to the power n minus 1 dt. So, you observe that beta function is proper if m greater equal to 1 and n greater equal to 1. This is proper if both m and n are greater equal to 1, but if they are less than 1, both of them are less than 1, then two types of improperness will be involved, type 3 and type 4. So, we in order to discuss the convergence of this integral, we have to break the limit of integration, break the range of integration into two parts, as was done in for gamma function. So, here also let me write 0 to a the integrand inside, and then a to 1 dt. So, now a is again a real number which lies between 0 and 1. Okay. So, now you can see this might be of type, this is at 0, improperness it is at 0. So, type 3 integral. For the second case, the improperness is as the function becomes unbounded at the upper limit. So, it is of type 4. So, let us call again I1 and I2. So, this is the beta function can be expressed as a sum of the two integrals I1 and I2. So, now let me write I1. I1 is 0 to a t to the power m minus 1, 1 minus t to the power n minus 1 dt. So, now again we will apply limit test to check the convergence of both I1 and I2. So, for I1 the problem is at t equal to 0, and so we will if f x is the integrand, if we call the f x as integrand. So, to apply limit test, let g x equal to simply t to the power m minus 1. So, that f by g is what? F by g is t to the power n minus 1, and so which tends to simply 1 as t tends to 0. Therefore, again the limit is finite and non-zero. Therefore, integral f x dx and integral g x dx both will converge or diverge together. That is, if integral g dx converges, then integral f dx converges. If integral g dx diverges, then integral f dx diverges. So, therefore, integral 0 to a f dx and integral 0 to a g dx will converge or diverge together. So, now what about integral g dx? Integral g dx equal to, so now 0 to a integral g dx is equal to 0 to a this is I am sorry, this is let me go back to the previous page. So, everywhere I have written x, but it shall be t, please correct it, it shall be t, because it is t to the power m minus 1, 1 minus t to the power n minus 1. So, this will be everywhere it will be f dt, g dt will converge or diverge, this the two integrals will converge or diverge together. Okay. So, now integral 0 to a g dt is 0 to a t to the power m minus 1 dt. So, I can write this as dt. So, t to the power 1 minus m. Okay. So, now this is a type 3 integral and this converges, which converges for 1 minus m, this is less than 1, that is converges for m greater than 1, m greater than 0, m greater than 0, and diverges for 1 minus m greater equal to 1, that is for m less or equal to 0. Okay. So, thus same will be the nature of convergence of integral f dt. So, that this is equal to 0 to a dt, this converges for m greater than 0, diverges for m less or equal to 0. Okay. This is for I1. Next, let us tackle the next integral I2. So, this is a2 1 t to the power m minus 1, 1 minus t to the power n minus 1 dt, and this is a type 4 integral, improper integral. Then and the function becomes integrand becomes unbounded at t equal to 1. So, we need to apply the limit. If we apply limit test, we need to apply the limit as t tending to 1. So, we have to choose the comparison function g t carefully. So, here which to apply limit test, what shall be the comparison function? Here now g t should be 1 minus t to the power n minus 1. Okay. So, let us take g t equal to 1 minus t to the power n minus 1. So, that if I call the integrand as f t, then f by g is t to the power m minus 1. Therefore, we need to apply as t tending to 1, f by g equal to limit t tending to 1, because the integrand becomes unbounded at t equal to 1. It is a type 4 improper integral. So, t m minus 1 equal to 1. So, again the limit is non-zero and finite, and therefore, this is therefore, if integral g dt converges, then integral f dt converges. If integral g dt diverges, then integral f dt diverges. Therefore, integral f dt and integral g dt converge or diverge together. So, this is from a to 1, a to 1. So, let us check for what values of g dt converge or diverge. So, now integral a to infinity g dt equal to a to infinity 1 minus not infinity, I am sorry, this is a to 1, 1 minus t to the power n minus 1 dt converges when, so this is equal to what? A to 1, I can write it as dt by 1 minus t to the power 1 minus n. So, when this index is, it converges when the index 1 minus n is less than 1. When 1 minus n is less than 1, that is when n is greater than 0, and diverges when the complementary case 1 minus s to 1 f dt, which is equal to a to 1 t to the power m minus 1, 1 minus t to the power n minus 1 dt converges when n greater than 0, and diverges when n is less or equal to 0. So, now we can combine the two cases. So, beta m n equal to I 1 plus I 2, its form is 0 to 1 dt. So, I 1, this converges for m greater than 0 and proper for m greater equal to 1. This is improper and converges for m greater than 0 and proper for m greater equal to 1, whereas I 2 is improper and converges for n greater than 0, and it is proper for n greater equal to 1. So, for it is the I1 converges for m greater than 0, but it is proper for m greater equal to 1. So, I can say that it is improper and converges for, I should write it as 0 less m less 1. Similarly, I2 is proper for n greater equal to 1. Thus, if I write improper and converges, then for 0 less n less 1. Okay. Therefore, we say that beta mn equal to 0 to 1 t to the power m minus 1, 1 minus t to the power n minus 1 dt is defined for m greater than 0 and n greater than 0. So, whenever you define beta function, so there the two arguments m and n must be strictly greater than 0. So, for 0 less than m and n less than 1, they are improper but convergent, and for when m greater equal to 1 and n greater equal to 1, they are proper. So, it will always have some definite value. Okay. So, now let us do some problems with beta function and gamma function. First, let me prove that beta mn equal to beta nm. So, beta mn equal to beta nm, proof. So, beta mn is what? 0 to 1, 1 minus t to the power n minus 1 dt. Okay. Then beta nm will be what? 0 to 1 t to the power, in place of m write n, and in place of n write m dt. So, to prove that beta mn equal to beta nm, we need to substitute. In all problems related to beta and gamma functions, we need to substitute proper, you need to apply proper substitution. So, here what substitution shall we apply? So, let us take 1 minus t equal to z. So, this implies dt equal to minus dz, that is minus dt is dz, and so dt is minus dz. And then what about the limits? When t equal to 0, z equal to 1, and when t equal to 1, z equal to 0. Therefore, beta nm is 0 to not 0, this is beta nm is the lower limit becomes 1, 0, and t to the power n minus 1, t is what? 1 minus z. So, 1 minus z to the power n minus 1, and what about 1 minus t? Z, z to the power m minus 1, and dt is minus dz. So, due to this minus sign, we can change the limits, I mean the limits will be now 0 to 1, z to the power m minus 1, 1 minus z to the power n minus 1 dz, and z is a dummy variable. So, you can, this is in place of z you can write any alphabet. So, if I write again the alphabet t, then it becomes dt, which is equal to beta mn. Thus, we have beta mn equal to beta nm. In proving other properties or other problems, this property of beta function is widely used. Okay. So, this is the proof. Next, some alternative forms of beta functions. So, first of all, number 1, beta mn I can write 0 to pi by 2 sine to the power 2m minus 1 theta cos to the power 2n minus 1 theta d theta. Okay. So, now how to prove it? So, what is the original form of beta mn? 0 to 1 t to the power m minus 1, 1 minus t to the power n minus 1 dt. Okay. So, let us substitute, again you have to substitute t equal to sine square theta. So, if t equal to sine square theta, dt is 2 sine theta, then its derivative cos theta d theta, and what about the limits? When t is 0, you can see sine square theta is 0. So, theta is 0. When t equal to 1, if I take sine theta as plus 1, then theta becomes pi by 2. So, therefore, beta mn becomes 0 to pi by 2, t is sine square theta. So, sine 2m minus 2 theta, and 1 minus t means 1 minus sine square theta, which is cos square theta, and its power is n minus 1. So, 2n minus 2 theta into dt, dt is 2 sine theta cos theta d theta. Okay. So, that is equal to, you can see if you simplify, 2 comes out 0 to pi by 2 sine to the power 2m minus 1 theta cos to the power 2n minus 1 theta d theta. So, this form is also widely used for solving problems. Okay. So, you have to apply proper substitution to get alternative forms of beta function. There may be, I am going to show you only 2 forms, there may be other forms as well, but I think with proper substitution you can derive all the forms. Next is next is the form, let me tell you, yeah. Beta mn equal to 0 to infinity t to the power m minus 1, 1 plus t to the power n minus n plus m dt. So, let me write here clearly 0 to infinity t to the power m minus 1, 1 plus t to the power m plus n dt. Okay. So, for this, what is beta function? Original definition is like this, 1 dt. So, from there you see in the alternative form the limits are changed, these are from 0 to infinity. So, you have to substitute in a proper way. So, what shall we substitute? Let us substitute t equal to u plus 1. t equal to u plus 1. You can see that if so that u plus 1 equal to 1 upon t, u becomes 1 by t minus 1. So, you can see that if we substitute t equal to 0, it becomes infinity, first term becomes infinity minus 1. So, it will remain infinity, and if you put t equal to 1, 1 minus 1 equal to 0. And what about the limits? So, dt becomes minus 1 plus u whole square. So, and I can say t u, when t is 0 it is infinity, when t is 1 it becomes 0, and there will be 1 du. Therefore, beta functions looks like infinity to 0 t to the power m minus 1, that is 1 plus u to the power m minus 1 and 1 minus t, t is 1 by 1 u plus 1 n minus 1, and dt is what? Minus du by u plus 1 square. So, due to this minus sign, the limit becomes 0 to infinity, and in the denominator how many, what will be the power of 1 plus u? So, you see here it is m minus 1, here it will be n minus 1. So, m minus 1 plus n minus 1 plus 2, that is it will become this becomes 1 by 1 plus u m minus 1 plus n minus 1 plus 2, and if you simplify the bracketed quantity, that will become u plus 1 minus 1. So, u to the power n minus 1 du. Okay. So, it becomes 0 to infinity u to the power n minus 1 by 1 plus u to the power m plus n du. But I have told that this form is b. So, we need the power of the numerator is m minus 1, not n minus 1, but you see what about beta nm then from this form. So, if I say 1, so put from 1 beta nm is 0 to infinity u m minus 1 1 plus u, this is u, n plus m du. Okay. So, but beta nm is beta mn. So, from 2 we can say beta mn equal to beta nm equal to 0 to infinity t to the power m minus 1 by 1 plus t to the power n plus m dt. Again we have written t in place of u because the integration variable is simply a dummy variable. We can write any alphabet in place of u, we can write theta in place of u, we can write t or any alphabet. Okay. So, this is these are the alternative forms of beta functions. So, now based on that, let us solve a very nice example. Okay. So, find the value of dx. Okay. So, let I be dx. We will use the form beta mn equal to 0 to infinity t to the power m minus 1, 1 plus t to the power m plus n dt, this form. So, you can write this integral as a sum of two integrals or difference of two integrals, 1 plus x 24 dx minus 0 to infinity x to the power 6 24. No, if you multiply x to the power 8 and x to the power 6, this becomes 14. This becomes 14 dx. So, now you can see that I can write this integral as x to the power 9 minus 1, 1 plus x to the power 9 plus 15 dx minus 0 to infinity. This integral I can write as 15 minus x to the power 15 minus 1, 1 plus x to the power 15 plus 9 dx. So, if you compare with the form of beta mn, then it becomes this beta. What is the first integral? This is 915. And what is the second integral? It is beta 15 9. But you know that beta mn equal to beta nm. So, this is 0, since beta 915 is same as beta 15 9. Okay. So, this is one. Okay. So, next something about gamma function. So, some properties of gamma function. Gamma function. So, first of all I will prove that gamma, no, this is alpha gamma alpha. Okay. So, it is the proof is straightforward. We can prove it by applying integration by parts. What is the definition of gamma function? Let me write here 0 to infinity e to the power minus x, x to the power alpha minus 1 dx. Therefore, gamma alpha plus 1 will be, if I replace alpha by alpha plus 1, then it becomes simply alpha dx. Okay. You remember always alpha greater than 0. Now, we apply integration by parts. Then, if I take e to the power minus x as the first function, then it becomes minus e to the power minus x, x to the power alpha will remain as it is, limits from 0 to infinity, then one minus sign, but due to this minus sign it will become plus, and 0 to infinity. So, e to the power minus x, then alpha into x to the power alpha minus 1, that alpha I am taking outside, x to the power alpha minus 1 dx, the derivative of the second function. So, now you see, as you apply x tends to infinity, e to the power minus x goes to 0, and when you apply x tends to 0, x to the power alpha goes to 0 because alpha is greater than 0. So, this term is 0 plus alpha, this is 0. So, e to the power minus x, x to the power alpha minus 1 dx. Since e to the power minus x tends to 0 as x tends to infinity and x to the power alpha tends to 0 as x tends to 0 since alpha greater than 0. Okay. Now, what about the integral? You look at the form of gamma alpha, the integral is nothing but gamma alpha, therefore, this is equal to alpha gamma alpha. Okay. So, we have proved that you should remember that gamma alpha plus 1 equal to alpha gamma alpha. Okay. And then so next we shall based on this property, let us find what will happen to gamma n plus 1 when n is a non-negative integer. So, we have gamma alpha plus 1 equal to alpha gamma alpha. Therefore, gamma n plus 1 equal to, I can say n gamma n, that is the next integer into gamma n, that previous integer. So, n into what is the previous integer of n? So, that will be n minus 1 gamma n minus 1. Similarly, it is, I can write n minus 1, again the previous integer is n minus 2 gamma n minus 2. Okay. So, continuing in this way, we will have n minus 1, n minus 2 up to n minus n minus 1 gamma n minus n minus 1. Okay. So, what is that? N into n minus 1 into n minus 2 into up to 3 to 1 gamma 1. Now, what about the value of gamma 1? You see, gamma 1 equal to 0 to infinity e to the power minus x, x to the power alpha minus 1. Here alpha is 1 dx. Okay. So, this is equal to what? 0 to infinity simply e to the power minus x dx, because x to the power 1 minus 1, that is x to the power 0, which is 1, and then this is equal to, if you integrate, it will be minus e to the power minus x. I am not writing that minus sign, rather I am changing the order of the limit infinity to 0. So, it becomes e to the power minus 0 minus e to the power minus infinity. So, this is equal to 0 and this becomes 1. So, gamma 1 is 1. So, now in gamma n plus 1 we have product of n integers. So, what is that? N factorial. Thus, remember gamma n plus 1 is n factorial. This is another property. Also, you should also remember gamma 1 equal to 1. Okay. So, this is this is gamma 1. Now, the value of gamma half is also used in many cases. In many physical situations, the problems involve the value of gamma half. So, what will be the value of gamma half? So, before we find the value of gamma half, let us tell you about some result. It has a proof, but we will not prove it, that is beta mn is gamma m gamma n by gamma m plus n. This is the, you must memorize this result. It can be proved in the context of double integrals, but if time permits we will consider the proof, otherwise just remember this result. So, beta mn is this. Now, what is gamma half? So, if I say equation star, in equation star you put m equal to n equal to half, then beta half half is what? Gamma half into gamma half into gamma half plus half. Okay. So, gamma half square by gamma 1. Okay. Then, but we know that gamma half square by gamma 1 is 1. Therefore, what is gamma half? It is root over beta half half, beta half and half. Now, what about beta half half? So, we will use this form, beta mn equal to 202 pi by 2 sin to the power 2m minus 1 theta into cos 2m minus 1 theta d theta. This form will be used. So, this is 2 n minus 1. This is 2 n minus 1 d theta. So, this becomes 2 0 to pi by 2 sin to the power 2 into half minus 1 theta cos 2 into half minus 1 theta d theta. Therefore, beta half half becomes 2 0 to pi by 2 sin theta, its power is 0, cos theta, its power is also 0 d theta. So, it becomes simply 2 0 to pi by 2 d theta. So, 2 pi by 2 minus 0, that is pi. So, beta half half, the value of beta half half is pi, and you can see that gamma half is root over beta half half. Therefore, this implies gamma half equal to root over pi. So, also you remember these values. So, gamma half is root over pi, these are very important. Gamma 1 is 1, gamma n plus 1 is n factorial, n a non-negative integer, and gamma alpha plus alpha equal to alpha gamma alpha for all alpha greater than 0. You must remember alpha greater than 0, you cannot put alpha equal to 0, neither you can put alpha less than any value of alpha which is less than 0. Okay. So, this is about some properties of gamma function. Okay. So, next let me tell about another theorem which is called duplication formula. So, duplication formula is this gamma m plus half. We need the proof. Okay. So, prove that now proof. We have gamma m plus n equal to I am sorry, this is beta m, and we have to use the relation between beta function and gamma function. Gamma m plus n. Okay. So, now here if I call it 1, in 1 you put n equal to half. You know that gamma half equal to root over pi. So, in this result we will use that, but for that we have to little bit modify the form of beta function. So, then what about this beta m half equal to gamma m gamma half by gamma m plus half. You see, in the duplication formula gamma m is present, gamma m plus half is present, and also this gamma gamma 2m is present and root pi is present. So, gamma half will give you that root pi, and again, so let me give numbers to everywhere 2. Now, again in 1 you put n equal to m equal to n. So, beta mm becomes what? Gamma m whole square by gamma 2m. Why I have substituted m equal to n? Because you see we need that term also gamma 2m. That is why I have substituted in 1 I have substituted n equal to m, so that I can get the term gamma 2m. So, this is 3. Okay. Well, so now we need to modify, we need to see that what about beta mm. Okay. So, let us see that. So, what about beta mm? Beta mm is, this is, we shall use the form of beta function 2 0 to pi by 2 sin 2m minus 1 theta cos 2n minus 1 theta d theta. So, if I put both n, then it becomes sin 2m minus 1 theta cos 2m minus 1 theta d theta. Now, how to write this? You see, sin 2 theta equal to 2 sin theta cos theta d theta, cos theta, sorry, not d theta. So, then therefore, what about sin 2m minus 1 2 theta? That will be 2 to the power 2m minus 1 sin 2m minus 1 theta cos 2m minus 1 theta this. So, we have sin 2m minus 1 theta cos 2m minus 1 theta, but we do not have this term 2 to the power 2m minus 1. So, this if I need to express the integral in terms of sin 2 theta, then I can write, can we write this as 2 to the power 2m minus 1 0 to pi by 2 sin 2m minus 1 2 theta d theta. Okay. But now next we do not want this argument to be 2 theta, we need in form of theta or phi or something like that. That is why let us put 2 theta equal to phi. So, that 2 d theta is d phi, and what about the limits of phi? When theta equal to 0, phi is also 0. When theta equal to pi by 2, phi is pi. Okay. So, beta becomes, let me keep it as 2 to the power 2m minus 1 0 to pi sin 2m minus 1 phi, and d theta is d phi by 2. So, these two cancel each other. Now, again you see what has happened, the limits have become 0 to pi, but in order that we can write it in a form of beta function, we must have the limits as 0 to pi by 2. So, for that we have to manipulate like this, we split the interval from 0 to pi by 2 and from pi by 2 to pi d phi. So, in the first integral the limits are from 0 to pi by 2, but we need to modify the limits in the second integral. It is from pi by 2 to pi. So, we need to make it from 0 to pi by 2. Thus, what we do? We have to make a proper substitution. So, in the second integral, substitute what? Let me substitute phi equal to pi minus psi. Okay. So, or I can write psi equal to pi minus phi. Therefore, d phi is what? D phi is minus d psi, and what about the limits phi psi? If you put pi by 2, then psi becomes pi by 2. If you put pi, then psi becomes 0. Therefore, beta is 1 by 2 to the power 2m minus 1 the first integral plus, what about this? It becomes pi by 2 to 0, pi by 2 to 0 sine to the power 2m minus 1. What about phi? Phi is pi minus psi, d phi is minus d psi. Okay. So, you can see that there is a minus sign and therefore, the limit will become 0 to pi by 2 and sin pi minus psi is same as sin psi. So, it becomes what? This becomes, therefore, beta becomes, outside there is 1 2 to the power 2m minus 1 and inside the first integral is 0 to pi by 2 sin 2m minus 1 phi d phi plus 0 to pi by 2. Now, it becomes sin 2m minus 1 psi d psi. So, you see the first integral is same as the second integral, because phi or psi both are dummy integrals. So, we can write this as 1 upon 2 to 2m minus 1, 2 into 0 to pi by 2 sin 2m minus 1 simply theta d theta. So, now you compare this form with, so compare with the form beta mn equal to 2 0 to pi by 2 sin 2m minus 1 theta cos 2n minus 1 theta d theta. So, if you compare this integral and beta mn, so m is okay, m will remain m, but what about n in this integral? You see 2n minus 1 equal to 0. So, n equal to half. Therefore, I can write this as this is as 1 by 2 to the power 2m minus 1 beta m half. So, in this way beta and beta m half are related. Okay. So, therefore, we have obtained beta 1 by 2 to the power 2m minus 1 beta m half. Now, on both sides let us apply the relation between beta function and gamma function. So, in the left hand side beta function is gamma m by gamma m plus m, or in the right hand side it will become gamma m gamma half by gamma m plus half. So, 1 gamma m we can cancel from each side. Therefore, we have if I take gamma half gamma 2m equal to 2 to the power 2m minus 1 gamma m plus half. But gamma half we know that this is root pi. So, this implies root over pi gamma 2m equal to gamma half. Yes. So, I have got some questions, therefore, let me first answer to these questions. Kaushal has asked me some questions. So, first of all, do we check convergence for the improperness only? So, the answer is that yes, as I told you, gamma alpha is 0 to infinity e to the power minus x, x to the power alpha minus 1 dx. Of course, since it is an improper integral, also beta mn equal to 0 to 1 t to the power m minus 1 1 minus t to the power n minus 1 dt. So, we have to check whether these are, I mean we have to establish that whether for what values of alpha and for what values of m and n the integrals are convergent. Okay. So, it is obvious that when alpha greater equal to 1, I mean this integral is always improper. So, gamma alpha is always improper, but beta mn is proper when m greater than equal to 1 and n greater than equal to 1. So, you need to check the convergence only if it is asked, otherwise mainly you have to solve problems based on the different properties of beta gamma functions. Okay. So, as I already you have asked that in the relation between beta and gamma all real m and n will work. So, beta mn is gamma m gamma n by gamma m plus n. It works only when for which beta function is defined, m greater than 0, n greater than 0. Okay. So, including negative, no, negative value will not work. In higher studies, if you study complex analysis, so thereby there is a topic called analytical continuation. There in the complex plane, it can be shown that due to the property of analytical continuation, it can be defined, but for our purpose where we are proving that it is, I am repeatedly telling that you must take m and n greater than 0. Similarly, for gamma function, the argument must be greater than 0. So, all arguments involved in whether in beta function or in gamma function, the arguments must be strictly greater than 0. So, and okay, it is defined for 0.1, yes, it is defined for 0.1. Okay. So, if there is no more question, so let me go to the next problem. This is, it is an also you remember this formula gamma alpha alpha. So, again alpha greater than 0. So, remember. So, our next problem is going to be based on this property. Okay. So, well, this is using sin pi by a, sin 2 pi by a, sin 3 pi by a, sin a minus 1 by a pi equal to a by 2 to the power a minus 1. Here a greater than 1 is a positive integer. Using this identity, you prove that gamma 1 upon a, gamma 2 upon a, gamma 3 upon a, etc., up to gamma a minus 1 upon a, that is equal to 2 pi a minus 1 by a half. Okay. So, proof. So, let us take the quantity in the left hand side as this quantity as p. Let p equal to gamma 1 by a, gamma 2 by a, gamma 3 by a, gamma 1 by a. Okay. So, and you remember that gamma alpha, gamma 1 minus alpha is pi by sin pi alpha, that also we have to mainly use. So, gamma 1 by a, gamma 1 minus 1 by a, gamma 1 by a and gamma 1 minus 1 by a. But we are not sure what about how long a will continue. I mean whether there are even number of terms or odd number of terms. So, what we shall do here, we shall write p once again as gamma a minus 1 by a, gamma a minus 2 by a, gamma a minus 3 by a. In this way, if I write here a minus 3 by a, gamma a minus 2 by a, gamma a minus 1 by a. So, it is gamma 3 by a, gamma 2 by a, gamma 1 by a. So, what we do? We multiply both p's. We multiply this p with this p. Therefore, p square is what? So, we can group like this. So, if we group like this, so what happens? Gamma 1 by a, gamma 1 minus 1 by a. Similarly, gamma 2 by a, gamma 1 minus 2 by a. Continuing in this way, we will have gamma, this will be a minus 2 by a. Okay. So, gamma, you see I can write it as 2 by a, I can write it as 1 minus a minus 2 by a. So, this similarly the last pair can be written like gamma a minus 1 by a, gamma 1 minus a minus 1 by a. Okay. Well, so what about gamma 1 upon a, gamma 1 minus 1 upon a? From there pi by sin pi by a. Similarly, pi by sin pi pi alpha. So, 2 pi by alpha, 2 pi by a. In this way, continuing in this way, there will be gamma sin pi multiplied by this argument. So, a minus 2 by a pi into pi sin a minus 1 by a pi. Okay. Therefore, well, so now our next job is to apply the result what is given to us, that is product of sin pi a sin 2 pi by a etcetera equal to a by 2 a minus 1. Okay. So, then this is equal to 2 to the power a minus a. Now, how many pi's are there? You see 1, 2 up to a minus 1. So, if I take the product, the power of pi will be pi to the power a minus 1. So, that will become pi to the power a minus 1 divided by, now apply the result, this is a by 2 to the power a minus 1. Okay. So, that we can write it as this 2 will move in the numerator, 2 pi to the power a minus 1 by a minus 1 by a. So, this is p square. So, the p will be, if you take the square root of the entire thing, therefore, so from there I can write, therefore, p equal to 2 pi a minus 1 by a to the power half. That is what we required. Okay. So, this is one result. Well, so one more problem through which, one typical example rather, through which you can solve many other examples, that I must tell you, that is, yes, evaluate a to b x minus a to the power m minus 1 b minus x to the power n minus 1 dx in terms of beta function. So, solution. So, in this type of problem where the term is x minus a, where what is a is the lower limit, and here it is b minus x, what is b in upper limit. So, such examples you should substitute x equal to a cos square theta plus b sin square theta. So, x minus a is a cos square theta minus 1 plus b sin square theta. So, the first term becomes minus a sin square theta, so that it becomes b minus a sin square theta. Okay. So, similarly, b minus x becomes b minus b sin square theta minus a cos square theta. So, this is b minus a cos square theta, b minus x. Okay. Then what about dx? So, dx is, if you integrate the first term, minus 2a cos theta sin theta, and if you integrate the second term, 2b sin theta cos theta and d theta. So that it becomes 2 into b minus a again sin theta cos theta d theta. And what about the limits? So, if you put x equal to a, when x equal to a equal to a cos square theta plus b sin square theta. So, this implies a sin square theta equal to b sin square theta. This implies b minus a sin square theta equal to 0, but a and b are the limits, therefore, a not equal to b sin square theta equal to 0. So, we shall take theta equal to 0. Similarly, when x equal to b, we shall get b equal to a cos square theta plus b sin square theta, and so we are going to get now b minus a cos square theta equal to 0. So, this implies cos square theta equal to 0 and we take theta equal to pi by 2, since b not equal to a. So, the integral I becomes 0 when x equal to a, theta equal to 0, when x equal to b, theta equal to pi by 2, and we are having x minus a is b minus a to the power m minus 1 sin to the power 2m minus 2 theta. Similarly, b minus a to the power n minus 1 cos 2m minus 2 theta multiplied by 2 b minus a sin theta cos theta d theta. Therefore, how many b minus a's are there? If you add the powers of b minus a, m minus 1 plus n minus 1 plus b minus a. So, m plus n minus 1, and there will be multiplied by 2 0 to pi by 2 sin, what will be the power of sin? 1 2m minus 2 is here, here is another sin theta. So, 2m minus 1 theta, and what about cos? Power of cos is also 2n minus this is n. So, this is actually n, 2n minus 1 theta d theta. And what is that? This is equal to beta mn. Thus, the given integral is nothing but m plus n minus 1 beta mn. Okay. Well, so based on this you can solve many problems. I have some problems for you, but if I write this, it needs some time. So, I will scan the problems together with the solutions and send it through email. Okay. Thank you for today. So, we will meet again on Tuesday. Thank you so much.